Hello, and thank you for visiting today. Today's video is about Unit 1, Lesson 5 of Desmos, Grade 6, Exploring Triangles. The main objective of this lesson is to get you to use different strategies for finding the area of a triangle. I'm going to demonstrate for you 3 different strategies. One of them I don't like, and you'll see why I don't like it when we get there. But let's take a look. Okay. Here's this triangle. I want to find its area. Area is the number of squares inside the shape. However, some of these squares, as you can tell along the edges, are not whole squares, so we can't just count them. So here's the first thing that I'm going to do. I'm going to draw this line segment right here, and that cuts the triangle into 2 pieces. They're not equal to each other, so they're not halves, but it's 2 pieces nonetheless. And then I'm going to take this triangle that's on the left, and I'm going to double it and make this rectangle. Since I've doubled it, this original triangle is only half of what the rectangle is. So we're going to find the area of the rectangle and then divide it by 2 to see the area of this piece of the triangle. Okay, this is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rectangle is 3 times 10 is 30. But remember that this part, this small triangle here, is only half of the original rectangle. So therefore, we have to divide that by 2. And that turns into 15 square units. However, that's only part, in fact, a small part of the original giant triangle. So now we have to find the part on the other side. Well, I'm going to do the same thing that I did before. I'm going to double it. And again, we're going to take that rectangle and then divide it by 2 because the triangle only takes up half of the rectangle. We know that it's 10 because it was 10 over here, so it's 10 over here. Let me count down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll do 10 times 10 is 100. But remember that we want half of that because we only want to count this part, not that part. So that's half of the rectangle. So we'll divide it by 2, and we get 50. Half of 100 is 50 square units. So now we know that this part over here is 15, and this part over here is 50. To get the total for the whole triangle, I'll do 50 plus 15. 50 plus 15 is 65 square units. So that idea was to draw the vertical line in the middle of it, not the exact center, but the middle, and then cut that into 2 small triangles, turn those triangles into rectangles, find the area of the rectangles, and divide by 2, and you've got your answer. All right, let's try another one. Here it's the exact same triangle. Since it's the exact same triangle, our area that we get had better be 65 square units. Okay, instead of drawing that vertical line, I am still going to double it, but I'm going to double the entire triangle. We know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, because 10 and 3 makes 13. So I'm going to start by drawing a line segment that is 13 units long up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then I'm going to draw this down here, connecting that part to that part. Do you see that this triangle and this triangle are the same size as each other? That they're just one is the same as the other, but the other is upside down? So since that's the case, I could find the area of this whole shape and then divide by 2, and I've got the area of the triangle because the triangle is half of this whole shape. But what shape is it? Well, look. That shape is a parallelogram, and you know how to find the area of a parallelogram. Parallelogram is area equals base times height. Well, the height is right here. How long is that? We know from before that it's 10, and here's the base. The base is 13, So to get the area of the whole thing, we'll do 13 times 10, base times height. 13 times 10 is 130. But remember, that was the whole parallelogram. We don't want the whole parallelogram. We only want half of that. So we have to divide by 2. So 130 divided by 2 is 65 square units. And notice it's the same as we got before. So we have a good amount of confidence that that is correct. So one strategy, turn each part of the triangle into a rectangle, find the area of each part and divide by 2, and then add them together. Second one, double the entire triangle to become a parallelogram, find the area of the parallelogram and divide by 2, and you get the area of the triangle. Third method, okay. Here, I'm going to count all the squares. I'm actually going to start by drawing that line segment again. I'm going to count all the squares inside. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Now, did I make any mistakes, skip any numbers or anything? I don't think that I did. Now, look at this little piece here. See how that's half of a square? So I'll combine these two together, and that makes 46. Combine these two together, and that makes 47. Combine these two together, and makes 48. Combine these two together, and makes 49. Combine these two together, and I get 50. And that leaves this one over here. Well, I have a problem. There are some whole squares here, but there are some partial squares also. And that little partial square, that's not half a square. So I'm actually going to do a hybrid. To count those squares, I'm going to do what we did in the first method. I'm going to turn it into a rectangle. 3 by 10 is 30. And 30 divided by 2 is 15. So that's 15. So over here we have 15. Over here we have 50, and 50 plus 15 is 65 square units. I don't like this method because I was able to count the squares on the right because everything was either a whole square or a half a square. I wasn't able to count the squares on the left, so I ended up doing partially what we did in the first method. If I'm going to do that, why not use the whole first method rather than a hybrid like that? So it works, it gets the right answer, but I don't like it. If you like it, that's fine. You go right ahead and use it. It does work. Okay, do you understand the three methods? We've got turning it into two rectangles, find the area of each rectangle and dividing by 2 and then adding it up. Turning it into a parallelogram, find the area of the parallelogram and divide it by 2 and add it up, and we've got it. Count the squares when you can, combine the halves together and do what you can with the not halves. So, here's another triangle. I want you to find its area. Use any method that you want. It doesn't matter to me. I won't be able to tell what you're doing anyway. So, try it on your own, pause the video, and then I'll come back and I'll explain the method and see if you're correct. Pause. Okay, you ready? So, I think I'm going to do the rectangle method. I'm just choosing that way. It doesn't matter what you did. You should have the same answer as I got. So I'll do that. Okay, this is 4 by 4. 4 times 4 is 16, but divide that by 2, and that half is 8. So this is, oh, why am I scribbling? I'll just write an 8 in there. Okay, and this is 1, 2, 3, 4, 5, 6, 7, 8 by 4. That's 8 times 4 is 32, but we want half. So that's 16. So to get the whole thing, I'll do 16 plus 8 is 24 square units. Did you get 24 square units? Do you understand some of the procedures for finding the area of a triangle? I hope that you do. Remember, if you have any questions, ask your teacher.